De-Broglie waves. So, by the Einstein photoelectric equation, it is concluded that the light is a wave. That wave property of the light is also having the particle nature. So, what is that particle nature? That particle nature means photon. So, the light is made up of huge number of quantas of photons. That photon is a particle. So, the De-Broglie argued that how the waves, that means the waves have the particle nature, that is the waves has a photon, the light waves has a photon particle. Why the particle does not emit wave, that is why the particle does not possess wave. So very simple concept. He says that whenever the particle is moving with the certain velocities, definitely that particle has a mass. So if the particle of mass m is moving with the velocity v, there will be a waves associated with that moving particle is called matter waves or De-Broglie waves. So he proved that energy E is equal to h nu. This is a photon energy, particle nature of the wave. Then E is equal to mc square. This is an Einstein equation, mass energy equivalence. So both are the energy E is equal to mc square. That is h nu is equal to mc square. We know that nu is equal to c by lambda, which is equal to mc square. This c and this c get cancelled. Then we get lambda, which is equal to h by mc. So this mc comes here and lambda this here. So the c is the velocity of the light. If we take the velocity of the particle mv, so the lambda which is equal to h by p, that is the momentum of the particle, that is mv. So this is the equation derived by the De-Broglie for the waves associated with the moving particle whose velocity is v and the mass of the particle is m, means the wavelength of that particular moving particle's wave is lambda is equal to h by p. So the scientists are very much understood here, they are logically it is correct. So they may ask that even the particle is moving with certain velocity, if you are able to write this wavelength, that is a De-Broglie wavelength in terms of energy, means he expressed these De-Broglie waves in terms of energy. So the energy means kinetic energy is equal to half mv squared. So 2 will become this side. So 2e which is equal to mv squared. Multiply m on both sides. 2me which is equal to m squared v squared. That is mv the whole square. So root of 2me which is equal to mv, which is equal to momentum of the particle. So lambda which is equal to h by p. Instead of p, you can write h by root of mg, where m is the mass of the particle, e is the energy of the particle, h is the Planck's constant. So he expressed this De-Broglie waves in terms of energy also. So very simple students, this is the equation for De-Broglie or matter waves, the waves associated with the moving particle. Then the same De-Broglie waves in terms of energy is given by lambda is equal to h by root of 2me. So the De-Broglie waves for electron. So whenever the electron is moving, that energy is equal to EV. So V is a voltage applied, so we can subtract that EV not a stopping potential. I can say that it is a EV or EV naught. Okay, that is a applied potential. You can take the potential. So if the V voltage is applied on the electron, the energy possessed by this electron is EV naught. So this energy is equal to kinetic energy of the electron, EV. So mv square which is equal to 2ev. So m square v square is equal to 2ev. V is a potential difference. This v is a velocity of the electron. So m into v which is equal to whole square which is equal to 2ev. Then mv, that is velocity. So mv which is equal to momentum which is equal to root of 2ev. So that is the thing. So sorry students, here we can take the m square, means we have to multiply with m, multiply with m, here also multiply with. So here m square comes, means what will happen? Multiply m on both sides. So m will become m square 2mv. So p is equal to root of 2mev. So that is the formula. So what is the De-Broglie wave? De-Broglie wave which is equal to lambda is equal to h by p, where h p is equal to root of 2m ev. If you substitute the value of h and mass of the electron and charge of the electron, we get the value 12.3 divided by root v, that is 12.3 Armstrong, the wavelength in terms of Armstrong. So no need to substitute the h value and the m value and the e value. Directly you can use this formula for problem point of view. So if the electron is applied with 24 voltage, means you have to substitute instead of V 24 and you find the number. This simplification number is equal to wavelength of the electron whose voltage is 24 voltage is applied on the particular electron. This is the wavelength of the moving electron. So we are derived the what is the De-Broglie waves. The waves associated with the moving particle is called the De-Broglie waves. The derivation for the De-Broglie waves is lambda is equal to h by p. Then the De-Broglie waves in terms of energy is h by root of 2m e, that is a capital E is the energy of the particle. Then the De-Broglie waves for the moving electron is lambda is equal to 12.3 Armstrong by root v, that is h by root of 2m ev. So these are all the points. So very simple unit. What is the photoelectric effect and the photoelectric equation? Graphs, photon properties, and then photoelectric laws. Then De-Broglie waves concepts are this unit. So this is a chapter number 11. Dual nature of radiation and matter is a very simple unit. You can score more marks by concentrating very few hours. So you can study these lessons within 1 or 2 hours itself. So prepare for the examination. For this unit, more important concentration must be given for even JEE and NEET questions from this concept.